take-home quiz. All right, so starting from the beginning. The first page was trash. People did not know how to do this or did not try. All right, so first off, when do we know that a reaction occurs in a single replacement reaction? Yeah, the element by itself needs to be higher on the activity series than the similar element in the compound. So let's just start at 1A. 1A. Do we have a reaction? Yes, because AL is higher on the activity series than PB. So we have a reaction. AL is going to replace AL solid is going to replace which element in the PbNO3 the PB. All right, so PB is going to be by itself. What phase is a metal? Solid. And then the AL is going to be with the NO3, and a lot of you put AL and O3 too. You disregard what the subscripts are. So you always disregard what the subscripts were in the reactants. You're going to pay attention to what charges the ions are, and then swap your charges and write your formula. So Al is a +3 charge, NO3 is a -1 charge. So what is aluminum nitrate? Al +3 with NO3 -1. Right. Al parentheses NO3 parentheses 3, and that is aqueous. Now balance this. And you get 2Al +3 PbNO3, 2 aqueous yields 3 Pb solid plus 2Al NO3, 3 aqueous. Any questions over that one? B. Zinc solid plus hydrochloric acid, HCl, aqueous. Do we have a reaction? Yes, because the N is higher on the activity series than hydrogen is. So we're going to kick out hydrogen, which what is hydrogen's formula? H2. And hydrogen is a gas. All right. And then zinc is going to be with the Cl. What is the charge of zinc? +2. Cl -1. So what is zinc chloride? GnCl2. Aqueous. And balance, and that's all just balancing. I think I'm going to do C and D and call. I'm going to do probably G. C, D, and G. Well, no, I'll do E and just go E. Okay, C, Ag plus KNO3. Do we have a reaction? No, because K is higher than Ag, so Ag is lower than K, therefore is a no reaction. All right. D, aluminum. This should be a familiar one because this was on your post lab for the single replacement and redox post lab. All right, do we have a reaction between Al and CuCl2? Yeah. Yes, so what is by itself? Cu is going to be by itself in the product, solid. And then Al is going to be with the Cl. Worry about your charges. Al is a +3, Cl is a -1. So what is the formula for aluminum chloride? AlCl3. Aqueous. Balance. And then that's all to it. Just a review, you do not need your solubility rules in single replacement reactions because the elements, if they are metals by themselves, they are solids. Metals by themselves are solids. Compounds are aqueous. Your genuines, most of them are gases. H2 is a gas, F2 is a gas, Cl2 is a gas. However, bromine is a liquid, Br2 is a liquid, and then I2 is a solid. And you do have to memorize your phases on your genuines. But it goes in order from solid gas to liquid, or gas to liquid to solid. All right, E. F2 gas plus Ki aqueous yields 1. Do we have a reaction? Yes, because F2 is higher than I2 on the activity series for nonmetals. All right, so we get I2 whenever you kick out a nonmetal, you're going to put a subscript of 2. And then we have to worry about charges. Now, it's in reverse order. Okay, you have to put the cation first. So K +1 with F -1. So what's the formula with K +1 and F -1? Kf. Aqueous. Balance this. And there you go. And I think I'll call it a day on page 1. Copper metal and silver nitrate solution. So what do we have? Our first reactant is Cu by itself, no subscripts. What phase? Solid. Don't put M for metal. That's not the case. It's S for solid. Metals are solids. All right, and then silver nitrate, we have to worry about charges. Ag is a +1. Nitrate is NO3 -1. So what is silver nitrate? AgNO3. And it says solution of, so what phase? Aqueous. Do we have a reaction? Yes, we do. So what's going to be by itself? Silver is going to be kicked out, and what phase is it? Solid. And then the copper is going to be with the nitrate. Now we do have to know the charge on the copper. If we are oxidizing copper, look on your activity series, and you will find that copper is a +2. So copper +2 is going to be with NO3 -1. So what's the formula for copper 2 nitrate? Cu parentheses NO3 parentheses 3. And that is what phase? Aqueous. Balance this. And there you go. Questions on the front page? For your transition metals, I think on the test I give you the charges. I reinforce the charges, but if I don't give you the charges, use the charge that's on the activity series. All right, and then ionic equations. Yeah. Yeah. Oh, yeah, sorry. And I agree too. Yeah, sorry, that changes the good eye. Sorry. Yeah, it should be Cu and O3 too. I said 3, but it should be 2. Sorry about that. All right, other questions? All right, 2. Now, a lot of mistakes on the net ionic and complete ionic equations. Not as many mistakes on the front, but still enough mistakes where I have to go over it in detail. On solids, liquids, and gases, you're going to keep them exactly the same. No charge, no nothing. Okay? And if you have a genuine, you keep it a genuine, meaning if you have Cl2 neutral as a gas, Cl2 gas, you're going to keep it Cl2 gas because those two chlorine atoms are bonded to each other. So you will reflect that. Now, if it's CaCl2, that's when you will kick out your subscript and make it a coefficient if it's aqueous. But if you have Cl2 by itself as a gas, you just keep it Cl2. Okay. But that is not the case with 2. You have zinc solid plus silver nitrate, 2 silver nitrate. Aqueous. Yields 2 Ag, 2 silver solid plus ZnNO3, 2 aqueous. Again, you keep solids, liquids, and gases the same. You do not put charges on them. Therefore, the zinc solid is just going to remain zinc neutral solid. However, what do we do to the 2AgNO3 aqueous? Break it apart. So it's going to be 2 Ag with its charge. If you forget, it's on your activity series. It's a +1. And then how many NO3s?
2.
2 NO3s. Because you keep everything the same about the polyatomic ion, but carry your balancing. Okay, the 2 Ag solid stays the same without a charge. And then what do we do to the zinc nitrate? The ZnNO3 too. It's aqueous. Break it apart in the Zn plus 2. Aqueous. And then what? Good. 2 NO3 minus 1 aqueous. Now, in single replacement reactions, you only have one pair of spectator ions. What is my spectator pair? And yeah, the 2 NO3 minus 1s. So the net ionic equation is zinc solid plus the silver cation, 2 silver cations, aqueous, yields 2 silver atoms, neutral atoms, solid, plus the zinc ion, cation, aqueous. Questions over that one? Okay. Let's do 4. Two aluminum atom solid plus 3 lead 2 nitrates, aqueous, yields 3 lead atoms solid plus 2 aluminum nitrate. Aqueous. All right. Complete ionic equation. 2Al solid, what do we do with it? Keep it the same. All right. What do I do to the 3PbNO3 2? Break it apart. And the what? The 3Pb. What charge? +2. Plus how many nitrates? Good. You have a number outside the parentheses, so that's how many chunks is in PbNO3 So you take the 2 and multiply by the 3, and that gives you how many nitrate ions. So 6 NO3 minus 1 aqueous yields. What do I do to the 3Pb solid? Leave it the same. So 3Pb solid. And then what do I do to the 2AlNO3 aqueous? Break apart into 2Al with its charge plus 3 aqueous plus what? 6 NO3 minus 1 aqueous. All right, what's my spectator pair? The 6 NO3s. And that ionic equation is 2 neutral aluminum atoms plus 3 lead-2 ions. Aqueous yields 3 lead atoms, neutral, plus 2 aluminum cations. Aqueous. Yeah.
Did you do A?
Yeah, I'm gonna make my way to it.
Oh,
All right, I'm gonna do 6 rather than 5 because 6 was a common mistake. 5 wasn't terribly bad, but 6 was.
Will we come in here again on Monday?
Yeah. I mean, if you have a study hall, that would be better.
I don't have a study yet.
Because my priority is to fifth period. I can try to help you. Magnesium solid, so number 6. Magnesium solid plus 2 hydrofluoric acid aqueous yields magnesium chloride aqueous and hydrogen gas. All right, be careful here. And this goes back to what I was saying with aqueous versus gas. Gas you keep exactly the same and do not put the subscript as a coefficient. Okay, solids, liquids, and gases you keep exactly the same. Therefore, Mg is going to stay Mg solid without a charge. What do I do to the 2HCl aqueous? Split it into what? 2H plus 1 aqueous, and then 2Cl minus 1 aqueous. Yields. Break the MgCl2 up into Mg plus 2 aqueous plus
Yeah, two.
2Cl minus 1. And see what I mean? This is aqueous. So we break everything up. We don't keep it Cl2. We bring the subscript out and make it a coefficient and make it an ion because it's aqueous. Now, the H2 gas is going to stay H2 gas. All right. What's my spectator pair?
Two.
The 2 chloride ions. So then that ionic equation is magnesium solid plus 2 hydrogen cations aqueous yields magnesium plus 2 ion aqueous plus hydrogen. Yeah. Any questions about complete ionic and net ionic equations for single replacement reactions? I should make mention you can only cancel out those that are exactly the same. Okay, they have to have the same charge, same phase, everything. Everything about them needs to be exactly the same. And that's why your magnesium solid did not cancel out with the magnesium plus 2. So this becomes really important that you make sure to put charges where charges need to go on aqueous things, right? And keep solids without a charge. Okay, this is different than precipitation because almost everything's an ion except your solid. Here, not everything's an ion. Okay. All right, now moving along. I don't necessarily have time to write this out on the board. I'll just do example problems and say it. And you can write down your notes when you watch the video again. Oxidation means charge goes up. Now, in the oxidation half reactions, we are losing electrons in oxidation. Therefore, when we show the electrons in the oxidation half reaction, the electrons are products. So that means they go to the right side of the arrow. Now, if you have a metal replacement, you have to make each side of the arrow neutral. So you're trying to get that many electrons to be neutral. Now, you're looking at total charge, not just the charge of the ion, but total charge. That means you take the coefficient and multiply by the charge to get your total charge, and that's how many electrons you need. In reduction half reaction, the electrons, we are gaining electrons, so the electrons are on the left side of the arrow. They are reactants. You always add electrons. You never subtract electrons. A lot of people wanted to subtract electrons. You never subtract. You always add electrons to the appropriate side. Oxidation means the electrons are products. Reduction means electrons are reactants. So that brings us to number 8. And we will do, we'll do number 9 to 8. The iron plus 2 ion, aqueous, plus cobalt metal, solid, yields the cobalt 2 ion, aqueous, plus solid iron. All right, the oxidation half reaction. Excuse me, charge goes up for oxidation, so for which ion or element did charge go up? The cobalt. Cobalt went from neutral to a +2. So we write cobalt solid yields cobalt +2 aqueous plus a certain number of electrons. This is easy because we don't have any coefficients. We need to balance out this +2 ion. So we need 2 electrons. The reduction half reaction. The other thing's going to be reduced, so it's going to be the iron +2 ion aqueous plus a certain number of electrons yields iron solid. How many electrons do we need to balance out the +2 ion? 2 electrons. I don't have time to do number 9. 11. Cl2 gas plus 2I minus 1 aqueous yields I2 solid plus 2 chloride ions aqueous. Now, with anions, oxidation and reduction still mean the same thing, but you have to think a little bit. Oxidation means charge goes up. So for anions, you're going to go from a negative to a neutral because -1 to 0 is going up. So the negative to neutral is the 2I minus 1 aqueous yields the I2 solid plus a certain number of electrons. Now here it's a little different. Oxidation's half reaction still means electrons go on the right. They're products. However, instead of making the two sides neutral equaling 0, you're going to make the sides equal the total charge negative. So you're making the sides negative, whatever the total charge is. Now, what you do to get the total charge, you take your coefficient and multiply by the charge, and that gives you how many electrons you need. So we have 2 times -1, so the left side is a -2. So how many electrons do I need on the right? Right, 2. Now the reduction half reaction is the other thing. It's going to be Cl2 gas plus a certain number of electrons yields 2 Cl minus 1 aqueous. How many electrons do we need? What's the total charge on the right? 2, -2, yes. So we need how many electrons? 2. Now, one thing to consider is that when you find the number of electrons in the oxidation, that has to match the number of electrons in the reduction. They always match the number of electrons. If they don't, you haven't taken into account the total charge. Okay, you have to take your coefficient and multiply by the charge to get total charge. So I will, as soon as this